wondering a little further afield from that that immediate question, and then sort of talking more about the fluid dynamics if the flow of oil is stopped. I think I recall you saying sometime earlier in one of these earlier briefings that basically whatever's out there is going to be sloshing around in the Gulf of Mexico. Is that? I mean, do we have any sense of what happens with what's in the water if the flow is stopped now?
So the question is, what happens to everything that's in the water once the flow is stopped? We don't have a sense for it. The models of, if you've looked at all at the surface images posted on the NASA website of where the surface oil is, one day it's over here, and the next day it's over there, and the next day it's down there, and then it's back over here. I mean, it's incredible how much it's moving around. Almost certainly the subsurface features aren't that dynamic, but they are moving. It's a moving target, and it's very difficult to sort of model it and get a feel for what's happening where. And when we don't know how fast processes are happening, I mean, we have an instantaneous measurement. This is what the rates were in the plumes at this date and time. We don't know how that changes over time. We don't know where the water's going. We don't know how the nutrient concentrations are changing. There are just so many. With modeling, you have to have more knowns than unknowns to make a reasonable model, and we have way more unknowns than knowns. So even making a simple model of how things are working out there is very difficult right now.
And you talked last time about there being a sort of surprising to you lack of coordination among what's going on in terms of the research out there. Have there been any steps since last time we were here in connection with sort of a more coherent and cohesive approach?
I wish I could say yes, but I can't. No, and I was just talking with a couple of people yesterday about this, and certainly there has to be more coordination than many of us are aware of. But in terms of there being a critical suite of variables that every ship in the area is tasked with measuring, and I think everybody is aware of the need to use NERDA-approved protocols, the natural resource damage assessment. There are certain legal obligations that you have to do this or that protocol or this or that measurement, and people are aware of that. And I think everybody is doing the best they can to make sure that they're collecting data consistent with the NERDA requirements. But I go back again and again to methane measurements and the lack of dissolved gas measurements, and it's in my opinion, this leak represents, it's a man-made disaster, but it is very much what could happen naturally with global climate change, with gas hydrate destabilization in the Gulf of Mexico. You basically have this massive injection of gas into the oceanic water column, and what happens to it? Where does it go? What regulates it? And it still is a research opportunity that I think is not being taken advantage of, and that's just independent of the absolute need to understand it with respect to this oil spill. But there's a larger context here with respect to global climate change and hydrate stability and instability, and so it's not just. I guess what I'm trying to say is there's more incentive here than just tracking the fate of this oil and gas. There's an opportunity to learn how climate change could impact this system, and we are missing it. And I think that's a problem.
So for lack of a better term then, what I think I hear you saying is this is sort of a fast-track way to look at impacts of global warming?
Yeah, with respect to methane dynamics, absolutely. And I think that, in the Arctic Ocean right now, hydrates are destabilized because of the higher temperatures in the Arctic Ocean. And that methane is getting into the oceanic water column, and we don't know what's happening to it. I mean, one of the guys in my group is actually going up there in 2 weeks for a cruise to measure that. But that's a very different system than the Gulf of Mexico. It's shallow, 70 meters water depth as opposed to 1,550 meters water depth. But the Arctic and the Gulf of Mexico have one thing in common, and that is they both are just prolific hydrocarbon basins, and there's tons of methane hydrate, literally, on the seafloor in the Gulf of Mexico and in the Arctic Ocean. And climate change is not going to destabilize the hydrates in the Gulf of Mexico tomorrow, but they're on that little dicey horizon of temperature, and temperatures don't have to go up a lot to destabilize these superficial hydrates. So it is a golden opportunity to improve our understanding of how such an event would impact the system. And I think it's really unfortunate that we didn't take full advantage of it, because it's not like, there was certainly an opportunity to do a better job of documenting methane dynamics in the system and as a result of this spill, and we have not taken full advantage of those opportunities to date, in my opinion.
Methane hydrants, that's basically ice.
It is ice, but it's ice that, think about it this way: if you have an ice cube of hydrate, just a little ice cube on the seafloor, you take that up to 1 atmosphere, you have 160 ice cubes of methane. That's the concentration of the concentrating factor of methane in these hydrates. It's a factor of 160. So at the seafloor, there's this much methane, and it's 160 times that at the surface. So there's a tremendous amount of methane stored in these hydrates in the Gulf and in other places. And they're one of the most sensitive components of the carbon cycle with respect to global climate change.
Can I ask another question from the phone?
1 second. Yeah. Yes, go ahead.
I just want to make sure I understand. You found what sort of change in microbial levels the farther you got out from the well itself, and how do those findings about microbial levels compare with findings about oxygen depletion?
Well, the respiration rates that we measure in the plumes are consistently high, and they're highest in this intermediate zone. With sort of when you get far away from the spill site, a lot of the organic matter has been reacted, so the respiration rates aren't so elevated, but the oxygen has already been drawn down. When you're really close in, you're just beginning to stimulate the microbial community, so you get elevated activity, but the maximum rates tend to be in this intermediate zone between 3 and 15 or so kilometers from the leaking wellhead. And we haven't processed all of the microbial counts. I don't even know how many samples there are. There are a lot of samples, probably hundreds of samples that have to be counted. But we've done samples from close in, from intermediate distance, and from far out, and from control sites that were impacted. And what you tend to see is consistently higher levels of biomass of microorganisms in the deep plume features. So.
And when you said, unless I misunderstood, when you said that you were surprised by the fact that respiration levels increased markedly over a 24-hour period, I'm not sure I understand that in the context of what you're describing just a moment ago about the distance. So the
respiration rates, they don't increase over time. You just measure them over a 24-hour period. So the microbial numbers doubled over 24 hours in the plumes.
In a specific spot.
In a specific spot. You basically take a sample of water from the plume and from above it and below it, and you measure the respiration rates. And those rates are consistently higher within the plumes than outside of the plumes, and the microbial abundance doubles in some cases, when you're in the plume over the course of that incubation. Now, the issue with distance is that by the time you're far away from the spill site, you've consumed almost all the gas that's in the water. There's maybe 5 to 10% of the gas remaining, and a lot of the signal with respect to organic matter, dissolved organic matter, has been depleted. So you don't see a big signal in color dissolved organic matter 20 kilometers from the wellhead. But what you do see is the signature of microbial activity that remains when you're that far away from the wellhead is a substantial depletion in oxygen concentrations relative to what you see close to the wellhead.